Hi everyone, and welcome to another part of the Solidity tutorials. In this part we're going to create another smart contract that here it works the same as this one, but with the integral. So using the integral, it makes our smart contracts much easier and much faster. However, you might not see the effect. They both work the same way and you might not see any differences, but it's more optimized if you use integral because it makes your job much more easier than what it is right here. So for example, you want to buy 1,000 tokens, so you don't have to, the code does not have to go loop through this for loop for 1,000 times in order to calculate the price of the 1,000 tokens, but all it needs to do is to use this mathematical integral in order to calculate it. So if you do a little bit of mathematics, you can make your code much faster and much more optimized. So in this part, we're going to do exactly that. So our smart contract will change. So right now, the first step is to create a new file here in the contracts folder. And here I'm going to call this bonding curve integral .sol. So here we go. So the first two or three lines are going to be copied, just the same as all other ERC20 smart contracts. So the first step is to write the name of the contract bonding curve, or I can say integral bonding curve, integral. It's that's not the right name for it. It's just for making it be sorted out from this bonding curve 1 and 2. So integral bonding curve, but this is not the name that we usually use for this kind of smart contract. It's just a method that we use in order to make our code much more optimized. So it's an ERC20 kind of smart contract, meaning that we use this ERC20 from this OpenZeppelin. And all we need to do is to open up the brackets and get us started with the contract. So just as always, what we had before, we'll have uint to 56 a and b. So a is going to be the same, it's 1, and uint 256 b, which is equal to 100. Here we go. And so also notice that these variables are public and constant. So public constant, and here public constant. So the next part is the supply, uint to 56 public total supply. So it's not total supply, it's supply, because we have the total supply already built in the ERC20.sol. We can use that, but here we're writing the supply and working with it for you to better understand what's going on. So we've got another mapping here from the address to the balances, address to uint to 56, address to uint to 56, public balances, and then we've got the constructor for the token, constructor string memory name, and string memory symbol. ERC20, and it will get the name and the symbol. Here we go, and don't forget the brackets. So this is the constructor, and so let's get it started with the first function, which is bind the tokens. So let's copy and paste from the previous one the only thing we need to change is the supply. So here we change the supply just the same as what we had in the first contract in the bonding curve. That's all. So we'll increase the let me fix this one first. We'll increase the total supply. So total supply or it is actually supply, so plus equal 1, actually token amount. So right here in this contract, let's see what happened. In this contract we used to one by one increase the supply, but here in the first contract we would change it right over here because we wouldn't need to increase it inside of the calculation of the if amount, right? And the reason we're doing this is because we do not want to increase it inside of the calculate if, because we're using the integral, so we don't have to get into a for loop and increase the supply one by one. Here we're just doing it straight and directly right within the function by tokens, because we do not need to go through a loop. We will just calculate the entire integral in just one move without ever needing to increment it one by one. Anyway, the same goes on for the cell tokens. So all I need to do is to copy and paste the cell tokens function here. So let me do it over here, and so here instead of plus equal 1 we'll have minus equal 1, and I'm gonna write it over here. So it's minus equal token amount actually. So the number of supply will be decreased by token amount. So again, the same goes on for the cell tokens. As you can see, we didn't have this instead of the cell tokens, but in the first contract we had it, right? So we would do this straight in here without needing to do it elsewhere. But in the second one, in bonding curve 2.sol right over here, we would write minus equal 1, because every time we would calculate the get current price based on the supply and add it with the ETH amount. But right now we're using integrals, so we don't ever need to do that. Okay, anyway, let me explain, if you haven't watched the other tutorials for bonding curve 2 and bonding curve, I'm going to explain what we did instead of the buy tokens and sell tokens. But if you have, you can skip ahead and go after the next function. So anyway, we would first calculate the ETH amount, which we will write it in the next part. But here we would calculate the ETH amount, and here the true, which we have written here, is actually the sign whether we're buying or selling. So for buying it is true, for selling it's false. As you can see here, when we want to sell the tokens, it is false. So it requires that the message, that value that the message sender wants to buy the token with, be greater than the ETH amount. So we would calculate the ETH amount based on the token amount that we want to buy. So this is the price of the whole tokens that we want to buy, and then we will check that we have entered the a specific value that is either equal to the ETH amount or greater than that. Otherwise, we'll show to the user insufficient funds. And here, instead of the mint, we will mint the number of tokens that we want to buy, and they will be minted to the address of the message sender, who is the buyer. And the number of the tokens that are going to be minted is the token amount, and then we will increase the balances of the message sender by this number of token amount. So the balances is for the balances of the tokens of that specific buyer or seller. So, and then in the end we will increase the token amount by the number of actually we will increase the supply by the number of token amount. So any number of amount of token that the person wants to buy will also be added up to the supply, meaning that they're minted, so the supply will also increase. Notice that we have another variable which is total supply, which is inside of the ERC20.sol. So whenever we mint the tokens or burn the tokens, that one will also be affected. So whenever we mint the tokens, the total supply inside of this contract will also be increased by the token amount, right? Or also be decreased by the token amount, right? So burn and mint will also change the total supply. But here for ourselves, because we have another variable for you to understand what's going on, here we have the supply in order to be a kind of an identifier of what we're going to do. If you are a professional programmer, you can just omit this supply and directly use the total supply parameter from here, but this is because this is for educational purposes. I'm also writing the supply variable and defining it at the beginning, also making it public so that I can see it in the mix. So that's it for this part of our tutorial. In the next one, we'll continue with the rest of the functions, the if amount, and we'll see what happens when we want to calculate the integral and also the rest of the functions. So that's it for this part.